Sensor network funded by DST SERV of rupees 29 lakhs, and also some other projects like design and implementation of parallel algorithms to find minimum spanning tree for large graphs, received a grant of rupees 1 lakh from TechWhip 2. So she is also a member of State Council of Higher Education Telangana State from 2016 to till date. Madam's area of interest, research area of interest includes parallel algorithms, security and privacy in online social media, CAD algorithms for FPGAs, routing protocols for wireless sensor networks, and managed GPU computing. She has published many papers in reputed journals and guided many research scholars. She has also published a book, many books, one such as like VLSI design, a comprehensive coverage of VLSI implementation technology, electronic design automation tools, and FPGA design. So we are honored and privileged to have you, ma'am, for gracing this occasion. We welcome you once again, ma'am, for this online
Thank
ATAL
you. Thank you,
Faculty
Deepa.
Development Program on augmented reality and virtual reality. Thank you, ma'am, for gracing this occasion.
Thank you. Thank you, Deepa. Uh, can I share the presentation now?
Okay,
Yes,
thank you,
ma'am.
ma'am.
Yes.
Ma'am, you're audible. Thank you, ma'am. Yes, ma'am, you can start,
Yes.
ma'am.
Is it visible?
Yes, ma'am.
Yes. So very good morning to all. And first of all, I should congratulate the CBIT Department of IT for getting this ATAL FDP course, for sanctioning this course, and particularly on this augmented and virtual reality reality area, which is actually a recent topic.
Good morning,
It's
ma'am. Good
a
morning.
good morning, and it is there are huge challenges, research challenges in this area, and many of the faculty can got a good opportunity by introducing this particular FDP program by the CBIT. So I congratulate the CBIT college and the Department of IT also, and head of the department and entire team. And also thank you for giving me this opportunity to be a part of this FDP program. Now I'll give the brief applications. There are huge applications are there in this particular augmented and virtual reality applications. I'm just stressing on very few applications, and my talk will be mostly concentrating on the research challenges. And it will be like a most interactive way. So all of you please interact with me through chat box. If because this is a FDP program, I think we can share the expertise from all participants, those who are attending, and also the speakers. It should not be like a one-way topic, one-way lecture. We are all teachers and we know, right? So we are all very good expertise in all these areas. Now I am going to, my talk is basically on introduction to augmented and virtual reality and what are the applications of this reality, that is augmenting and virtuality, and basic ideas of research in this particular area. I think most of the last 2 days sessions you might have attended. So can you just give the applications, any applications which you have seen already? Can you write it in a chat box?
Education sector, ma'am.
Education sector, good. You can write it in a chat box. Some of them Pokemon Go, health sector, good. And so health sector, can you give an example of health sector? Like what is it? Gamify, very good. Any example? Emulating virtual laboratory, particularly in this particular COVID situation, these virtual classrooms are very much useful, right? So this is virtual laboratories are helping us. Any examples which you have already attended the classes, right? E-commerce, very good. Like how that e-commerce comes into the picture, how this augment reality helping in e-commerce.
I mean, virtual showrooms, ma'am. Virtual
Yes, you
showrooms.
can write it in a chat box.
Okay. Okay, ma'am.
Yes, virtual showrooms, so that this online shopping can be more effective way, right? Any other examples? Ancient history cases. Uh, any so education sector is completed, and e-commerce is completed, and marketing, that is marketing is also there. Yes. Then gaming also is there, correct. Sports is also there, very good. So online convocation in IITs, that is also has done. So is it like a virtual thing or augmented particularly? Can anyone write the difference between augment and virtual reality? So this online convocation part, will it comes into the virtual reality, or a what is the mean augmenting? It's a mixed reality. Correct. Putting virtual object in a real world is a augment. Emulating, immersing in that virtual world is a virtual reality, right? Yes, it's a mixed reality. It's a mixed of this online convocation is a mixed reality. So true. Any other examples? Can any one of you now can write now? For example, you have given some of the e-commerce, right? Flight simulator. Yes, good example. Flight simulator is yeah. So with respect to the flight simulator point of view, or a driving simulator, or a military simulator, virtual tour, almost everything, all of you are aware of all these things, which I am going to give these applications now also. Same thing I am going to give. With respect to the virtual tour by tourism. So these are the examples which I am going to give in my lectures also. But particularly with respect to the research point of view, so what are the challenges with respect to, suppose I want to design a military training or a training device, right? So what are the challenges we expect with respect to the designer point of view? So with respect to the military training, so I wanted to design a application, you can say web application, where it involves a uh, mixed reality, we can say, right? The purpose of that application is to for the military training point of view. Just a minute, this is one. Right? the I'll go with my this. Right? So I think all of you have given the huge applications which are already existing, and same thing which I'm also have written here. Uh, we'll see one by one with respect to the research challenges point of view, and also what are the advantages and where they are using. Right? So a brief definition, though it may be repetition for you, but because the introduction point of view, I just have added one slide. So augmented reality is a term for a direct or an indirect view of a physical, real world environment whose elements are augmented by computer generated sensory input such as sound or graphics. So this is as per the Wikipedia definition, which is a standard definition which is given with respect to the Oxford Dictionary point of view. And with respect to the research point of view, that is article point of view, that is it is a field of computer research which deals with the combination of real world and computer generated data. So this is a basic definition of this, and I think all of you know the history of AR, which is introduced in the years 1986, right? And later on it is developed. And another that is in the 1997, he has given a formal definition, that is Ronald Azuma. He defined an augmented reality system as one which combines the real and virtual world aspects. So this is a real and virtual, like we have seen several examples. We have given several examples also. And one more example is a football game, or even in IPL also we are seeing nowadays, right? So projecting the ads on a screen, on a football ground, or a IPL cricket ground is an augmented reality. So which combines the real and virtual world aspects, right? So both can be seen at the same time. That is what we are looking at. Particularly with respect to the football game and an IPL, we can able to see that, right? And is interactive in real time with respect to the 3D environment or a three-dimensional environment. That means virtual interactive in real time means virtual content can be interacted with respect to the actual platform, a real platform. And also we can able to see the three-dimensional view. So that was, and this was mentioned, this definition is given in the year 1997, where he has introduced this augmented reality with respect to the interaction with respect to the virtual content. And what are the devices? Now how we are going to look into these things, that is, or placing into this, and then what are the devices or interfaces are required to project our this virtual content, right? And there should be a platform or an interface which helps you to identify the depth of that, or a dimensional view. So there are some examples I have given. There are many display devices are there, and even there are huge research challenges are also there with respect to the device point of view. That is, it should be a mobile computing device. So one is a head-mounted display device, and also handheld display devices, and spatial display devices. That is what a monitor-based ARs and projector-based ARs are there, and optical-based ARs comes under head-mounted displays, right? And also now retinal-based ARs are also nowadays the work is going on. That should be. So that means there is a huge challenge, research challenge with respect to the embedded devices point of view. That is, you can address with respect to the hardware component point of view. Those are working in an ECA background or IIT students, they can also think about of finding an interface or a display devices with a battery powered, with a energy efficient battery powered devices, where you can use those devices for projecting the augmented reality, right? So now the work with respect to in this point of view, the work is going on with the portable and wearable systems with a battery powered, with the energy efficient battery powered systems. And coming to the virtual reality point of view, again I have given a very standard definition, which is with respect to the dictionary point of view. And virtual reality is an artificial, a computer generated simulation or a recreation of a real life environment or a situation, immersing the user by making them feel like they are experiencing the simulated reality, primarily by stimulating their vision and hearing. So the virtual reality, this term was coined by Jaro Lanier. Right? He has introduced this particular term where this is an artificial or a computer generated simulation. So we are working with the various simulators now. Right? So this is a simulation is created where we can immerse in that by stimulating their vision and the sensors. That is the hearing and vision sensor. It is purely working on the sensor. So initially it is also called as immersive virtual reality, where user becomes fully immersed in a 3D world. So it is this also it is written as like this is one pictorial representation of virtual reality. So you are going to interact with the imagination or imaginary world, and you are going to immerse in that imaginary world. So these are some of the basic definitions with respect to the augmented reality and also with respect to the virtual reality. So these terms this work has started in the years late 80s and 90s, and slowly it is started in picking up in the years 2000. In the year 2001 onwards, it is started picking up with respect to various applications. Already you have mentioned the different applications like military applications you have given, and marketing, e-commerce, and education sector, health sector. There is one more sector is also there, which some of you have missed, that is disaster response sector, right? And tourism also already mentioned. So these are many applications are there where this augmented and virtual reality is there. And another major application with respect to virtual reality point of view is data visualization. Nowadays we are working with a huge big data. Like as I'm also heading the cyber security department center, I was working within some challenges with respect to the cyber security point of view. So it is like per minute there are a huge amount of data is traveling across the cyberspace. We all know that how many users are there. I think some study is also revealed in the last newspaper, I think you might have seen. Most of the adults from 18 to 40, they are spending more than 6 to 8 hours per day on only on the internet. I think this you might have already understood, read this news. The takeaway from that particular news is it has huge amount of data is traveling across the cyberspace, right? And what sort of data is traveling across the cyberspace? There's that data. What is the actual content in that data? What is the value of that content? And what type of data it is traveling across it? So I think you might be aware of the many cyber threats also, right? So attacks and phishing attacks, and then cyber bullying. So these are all some of the attacks or threats in the cyber space. So how do you visualize that particular data? So this is data visualization comes into the picture. Like you can also, if you visualize that data, so that we can analyze particularly with respect to each and every corner of the data. So it is like visualization with respect to the n-dimensional data. Visualizing in with respect to n-dimensional data, so that each and every corner of data we can also represent in a pictorial format, and so that we can able to analyze appropriately. So particularly analysis point of view, if you see what is the requirement for analysis point of view is sentiment analysis, which you know, where the sentiment analysis with respect to the cyberbullying point of view, if we talk with respect to cyberbullying point of view, what is the text message with respect to the Twitter, what is the text it is traveling, right? And Facebook, what is the text? So we can take the Twitter data and then analyze it, what sort of data it is sharing across the media or across the space, and then whether that particular data can be analyzed with respect to whether it is a hatred speech or stress related speech, or it is, are there any cyberbullying words are there in that, or any what you can say, any fake news is spreading. So all these things can be analyzed with respect to the simple example with respect to the Twitter data point of view, right? So this virtual reality or visualization of the actual data, the data can help in these aspects also. You can also think in those ways, those who are interested in doing research in this particular area. So you can also think. So visualizing the data from the whatever the Twitter or API and Facebook API, you can collect it and then analyze the sentiments. With that, you can also detect the stress levels of the users, stress level of the users, or are there any hatred speeches are there in that, or any cyberbullying words are there. So there are three different aspects you can also work in with respect to the visualization of the data by combining the sentiment. So this is like extracting the words and then analyzing the sentiments of the words, right? So this can be done with respect to the research point of view for the data point of view. And another experiences like we already mentioned, but again I have given here. So web-based applications are there. So web-based augmented realities, and you might have so any one of you have used that web-based one second. Any one of you have used any web-based ARs or any toolkit in your mobile phone, like embedding the, all our kids are working with that only, right? They are using all yes, Google AR. So all sort of they'll take the picture and then they'll apply all these images, right? Caps and goggles, and then correct. So that is one thing. Any other toolkit which Google AR, other than that Google AR, any other thing is there? Snapchat filters, okay. Sorry, this is coming. Any, okay. Are you there? Am I audible? You please chat in the chat box. Yes. So my question is, one of you is Google AR. So how that any one of you have started with working with overlaying the image? Yes. So what are the challenge? So what is that process? there is a application, AR application, right? Where you can install in your mobile phones or a desktop, where take a photograph in any garden. From your garden you can take a photograph, and you can in that photograph you can fix your, or you can apply the overlay any image on that particular photograph by fixing one particular location, right? So that is possible. So that is one application which all is like it is very useful for am I 1 second. One second, I'll join in 2 minutes. Rama, I'll just join in 2 minutes, ma.
Okay, madam. Okay. participants, ma'am disconnected, so ma'am will be back in a couple of minutes. So please bear with us.
Am I audible now? Sorry for the disturbance. We will move on to the various applications. So one is web-based AR. So we are discussing about the AR toolkit, Google AR and then Apple AR, right? And then how that AR application is working. That is what we were discussing. With respect to that application, some of you have used it. So those who have not used, also you can just try it and install it. And there are open source tools are also available. And so that if you install and then check it, then you will also get an idea of what are the challenges, or you can say what are the you can address some of the challenges which are not available in the existing solutions. So that is one of the idea which I was those who have told that the processing time, that is exactly correct, right point of view. You have said, and another what location you wanted to exactly fix it, and then how it is projecting in that. So fixing the location on a existing photograph or existing image is one of the challenge. So that is one challenge with respect to the overlaying the image on the existing image, overlaying the what you can say, the augmented image on the existing real image. That is one of the challenge with respect to the tool point of view. And there are many other challenges that we will see with respect to as we go on the next slides. And mobile augmented reality, where you can also use the GPS and compass tracking and gaming. And there are other AR experiences are there, which you already mentioned, that is marketing experiences, robotics, tourism, urban planning, some of you have not mentioned, so urban planning is also there. Navigation, already you mentioned. Product assembly and repair also mentioned. And e-commerce. These are all many applications are there with respect to the augmented reality. And also you can say that it's a mixed reality, combination of AR and VR. And we'll see some of the existing literature with respect to the mobile augmented reality, and we'll see what are the developments with respect to mobile augmented reality point of view.
Ma'am, sorry for interrupting you. Your PPT is not visible, ma'am.
Okay, I'll just share again once again.
Thank you, ma'am. Thank you so much.
Thank you. Now is it visible?
It's coming, not it, ma'am. Actually, you're presenting to everyone. Till now, it's just
Screen is visible to us,
screen
ma'am.
is visible, ma'am.
Yes, ma'am.
Yeah,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes. So the previous slide, which is there, this is what the same slide, and now with respect to the mobile augmented reality point of view, which I want to discuss, and it has, like, with respect to mobile augmented also, we what are the research work carried out with respect to last 20 years back or last 15 years back. That is what which I wanted to give some glimpse on that. So it has provided an opportunity to deliver information about the destinations in a much more natural and more straightforward way rather than checking online sources, maps, and travel guides. This is already there with in Google Map, but even then it gives some more information with respect to the augmented reality point of view. How this is introduced in this, and then what are the advantages and who has introduced all these things, we'll just discuss in the next few slides. And the major research focused on how the use of AR helps to improve the user knowledge and experience of a smart campus. That is with respect to tourism point of view. So suppose somebody want to travel from one place to another place. Now, with the help of this GPS, we could able to at least get the basic information about the where it is located and what is the area, and then how it is there, what are the availability, how the food is there, and how the transport facilities are there, how the accommodation can be done. All this information we are going to get it, right? So, but still, you can some more information can be helped with respect to the augmented reality point of view. How this use of AR can help us to experience the existing Gmap or Google Map or GPS images, right? So there is one author introduced about the augmented reality from the University of Jom. This is the University of he has introduced in the year 2018. That is new trends in using augmented reality apps for smart city context. In this paper, the author has mentioned about this particular augmented reality, which is RUZ, the University of Jom, which is introduced. He introduced an application. This is a mobile application where it functions mobile augmented reality guide application that supports users on the move by displaying information about the surrounding points of interest when a user selects on the screen of their smart devices. So this is a web application or an app, you can say, that supports users on the move by displaying information about the surrounding points. That is what we can able to see. How the points of interest when a user selects on the screen of their smart device is coming into the picture is again data mining, right? Again, accessing the point of interest means again accessing the users' reviews also they are taking with respect to those inputs and the GPS positions and other relevant information as selected, and then using this augmented reality, with the help of this augmented reality, they are giving some more information with respect to the user's point of view. And there are other applications are there, military-based applications, where the naval research has sponsored AR research on how this particular vital information, like what are with respect to the military point of view, what is the vital information with respect to surroundings point of view, right? And with respect to medical applications point of view, how it is used, and education point of view, how it is used. These are some of the applications. So with respect to medical image point of view, superimpose an image from an MRI onto a patient's body, which helps us to clearly analyze that. Like you can see clearly where the particular, for example, a tumor, in respect to the tumor point of view in the heart, in the lungs, or in a brain tumor, or anywhere, you can able to analyze that where it is actually located and how the uh, uh, image, like what is the location and the size and everything can be analyzed by using this augmented reality. And this particularly helps for the surgeons for before, it's like before going to onto the actual place. So this is giving a clear view for the surgeons. So we'll see with respect to the research, like researcher point of view, with respect to the existing literature point of view. I have given some of the literature work which was carried out in the 1986, where the Roberts et al. He has executed the first medical augmented reality system. That is what we have seen in the right, where he superimposed the pre-operative computerized tomograph, that is CT scan, in a proper position, scale, and orientation. So this actually started in the year 1986, where this that is what I was just mentioning, that is augmented realities. It started in the year 1986 onwards now. So he has identified what you can say, he has superimposed the already CT scan data by properly locating the position, scale, and orientation. So this is one of the challenge. That is what I was just telling. Tracking the actual location and placing at that particular place, and also the orientation with respect to the location point of view. That is whether it is a vertical or a horizontal or diagonal wise, how that is orientation, right? That also is required. So these are some of the research challenges. How do you locate identify the orientation and fix it on that particular or superimpose on that existing real image? So that is one of the challenge with respect to the medical point of view. So 1986, they have first started with respect to the augmented reality point of view. And with respect to the military application point of view, US Army have introduced, this is called as a land warrior, that is LW, this program. They have introduced an intelligent agent based, like we all know that there are military applications are there, right? So what are those applications? I have listed here. They have introduced an intelligent agent based decision support system on this land warrior's wearable computer by providing a perspective view in the weapon sight. I think all of you got it, right? So there is a wearable computer they have designed, and that gives the perspective view in the weapon sight, like what are the directions it is there, and complete view in 3D perspective point of view. By wearing that particular device, you will be able to find out which location the weapons are there and what is the view of that, or projection perspective view of it. And another Canada Institute also has started this. So they have introduced an helicopter night vision system, which was developed by Canada's Institute for Aerospace Research using AR. So what they have used is to expand the operational envelope of rotorcraft, which is helicopter night vision system they have introduced, where the pilots will ability to navigate in the degraded visual conditions. That means even a night vision or a dull environmental condition is not supporting, then also it helps that, like this particular AR model they have developed to analyze in the uncircumstances environmental conditions also, or you can say ability to navigate in a degraded visual conditions. So this was a project taken place by the Canada's Institute for Aerospace Research, which is used for enhancing the pilot's ability to navigate. So it is used for training purpose also. And they also introduced the uh, advanced helmet mounted display, that is AHMD, which is used to provide training for military personnel. That is what I was just mentioning previously, by overlaying actual augmented and simulated visible environment. So they have introduced a helmet which is mounted, that is you can also use it same as like a what our helmet is there, right? But it gives a helps for training point of view, that what is the actual scenario and augmented scenario and the simulated visible environment scenario. All these three are incorporated or by overlaying on the actual real image, and then they could able to train it. So this is used for a training purpose for military personnel, so that they can able to excel in the actual real-time environment. And so those are some of the research carried out. In the year 2001, they have used it. Sorry, not in the year 2001. This is in the year 2015. I forgot to mention here. So in 2015, they have introduced this helmet-mounted display. Yes. And this is with respect to the military applications point of view. These are the developments. And coming to the tourism point of view, they have introduced in the 2001. This is what I mentioned here. So they have introduced the augmented reality on a mobile augmented reality, you can say. It's an application where this is like it's overlaying the data on the user screen by giving the complete picture of the site where they are going to check it, like cultural sites where they are visiting, right? So tourism with overlaying intuitive data on the user screen by introducing this mobile AR with respect to the tourism point of view. And this is an Archeo guide. This is AR-based tourism guide, which is introduced by Valansky et al. These are the authors in the year 2001, which gives the intuitive data on the user screen about the place where they are going to visit, or cultural heritage sites. For all cultural heritage sites, they have developed an Archeo guide, which is a web-based application, mobile application, which is AR-based tourism guide, right? So they are used for giving the information on the user's screen. And another AR-based mobile application they have developed, that is a wearable called as wearable device, which is called Wire, WHYRE, which is a context-aware multimedia guide to turn museums and archaeological sites into communicating machines. So we can, it's a wearable device where it gives the information about while walking along that, you can give the it gives audio with respect to the all sites which are visiting. So that's why it is called communicating machines about the sites. This is then audio is also incorporated in that to give the information about that particular sites which are visited. And another application which is developed in the 2007, he is Hu and Ukimura. He proposed a new concept of direct visual navigation, which is superimposing the virtual direction indicators and traffic information into real road scene, providing expert guidance to the drivers. So this application is with respect to the navigation point of view. So we have seen the related work with respect to the tourism point of view, that is the Archeo guide, and Wire is a wearable device. And with respect to the tourism point of view, there is a direct visual navigation application is developed by Hu and Ukimura, and they have superimposed the virtual direction indicators and traffic information onto the real road scene, like what we are seeing in a GPS in Ola, right? So the traffic indication onto the real road scene, providing guidance for the drivers. So I think all of you are using the Ola and the Uber, right? So by giving these virtual indicators and traffic information Is there any advantage is there or any disadvantage? Hello? Hello?
Yes, ma'am. Yes, ma'am.
Am I audible?
Yes, ma'am. You're
Yes, ma'am.
audible, ma'am. Mostly there are only advantages, ma'am. As far as I know, because
Yeah, so so same thing which I wanted to tell again. There is a visualization errors are there. Measuring the location of an object, right? So
yes, ma'am.
giving traffic information, measuring the location of an object. I think you might have experienced some of the reasons also by using Ola GPS system, right? So
Yes.
there will be some directions it shows, but there it is some construction work may be taking place, but still it shows the direction,
Yes,
right?
yes.
Yeah, these are the challenges. So there are advantages are there, but at the same time there are also challenges are there to look into those factors, and then you can carry out your research. So that I just wanted to mention with respect to this application point of view. And also exact locations also you should able to measure. And another application, the proposed work with respect to the navigation point of view is they have proposed image overlay on optical see-through display. So there is a see-through display device on the front glass of the vehicle. I think we are experiencing now in all cars and are available already, right? For navigation, minimizing accidents caused due to shifting of gaze from the road to the console. So this is another work which is proposed, and which is there are good observations. Accuracy is there. The maximum accuracy is there achieved with respect to the image overlay point of view, with respect to the optical see-through device. And coming to the another application with respect to the education point of view, which I didn't mention in detail, but I'll show some of the aspects. So as this is one of the sentence I've just kept it here, is education with AR has proven to be extremely useful. We all know that how the students can, there is a challenge for the teachers is that we have to motivate the students, and particularly in this screen age students, screen age era, right? So they're all working with only the mobile phones. So for teachers, there is a huge, major challenge that we have to motivate them, or we have to motivate them for the learning process. So this AR-based applications are really helpful for motivating the students. So we have to, this AR helps us to supplement the real world objects with the virtual objects coexisting in the same space. For example, I've given one simple example, superimposing the invisible phenomena in physics, such as electromagnetic forces, or repairing, or repair works, magnetic, right? Gains the knowledge. And also if you show this with respect to the AR based application, then memory retention also takes place. It helps for the students to, for improving their learning capabilities. With respect to education point of view, how the AR can be used, that is one application which I just want. And coming to the disaster management point of view, which is a complex process, as all of us know that, with lots of uncertainties, incomplete information, and requires instant decision and action. That is a disaster management. So the major challenge in this case is, during a disaster guidance for performing relief operations. Now robots are used now for identifying where the disasters are occurred, and then they are getting the information. Once they're getting the information, then we should be able to identify what is the depth of that particular location where the you can give the support, right? So this augmented reality system helps for that, for earthquake disaster response, which overlays different invisible disaster relevant information. That is, Example, people buried by the rubble, simulations of damages and measures. All these things can be overlaid on the real-time environment, and then you can able to analyze the depth of a particular place, like, and then you can able to give the support, or you can able to perform a relief operations. This work has taken place in Turkey in the year 2004 by giving the information about the by overlaying the different invisible disaster information, by overlaying on the existing image by disaster information, like if any disaster occurs, how much depth it goes, and how much depth the people are buried, or and what is the damage has taken place. So all these things can able to estimate, and then you can able to visualize it. With that, you can able to perform good relief operations. It will be a guidance for performing a very good relief operations. So some of the glimpse I have shown. This is a surgery going on with the help of the robotics. All right. So this is all one advantage. And here, this particular right side, this is a military personnel taking a training by using this augmented reality. And this is a one mechanical experiment where they are showing the nuts inside the depth of the machinery. So this is with respect to the learning point of view, how it is advantageous for the students. And another disaster application was developed in the year 2015, that is Brunetti. He presented a wearable AR collaborative system, which is called as a SMART, SAFE, that is Smart Augmented Field for Emergency, which is integrated with the intelligent agents and multi-agent systems with the purpose of helping first responders and operators involved in a rescue mission. So they have introduced integrated with the intelligent agent systems and multi-agent systems with the purpose of helping first and responders. That is, here in this case, the question here is how the information is collected and then visualized, and this visualization, and from the existing with, and after visualizing, we have to extract the relevant information, or we can say we have to infer the relevant information. So that can be extracted with the help of this intelligent agents or multi-agent systems as introduced to acquire the relevant knowledge. So that can be visualized. So that is what this work they have done in with respect in the year 2015, and so that can be shown for the first responders, so that they can involve in a rescue mission. And AR mobile interfaces, which helps in enhancing training efficacy for on-site crisis preparedness activities. There are mobile interfaces are there which helps for training point of view for on-site preparedness activities. Sorry, one second. Right. And this is another just one use case. I just wanted to give in details about that, and then we'll quickly go to the next point. And as a market point of view, which is from 2007 to 23 in healthcare sector, there is an annual increase, 23% increases it seems. That is a huge market is there for the AR. Now, one example which I just wanted to show here, not in detail about what actually in healthcare sector, how the surgeons are get the help uses this particular AR facility. So that is patient and doctor education. This is use case, that is surgical visualization and disease simulation to enhance patient treatment and outcomes. All these things are with respect to the healthcare point of view. So one IR application maps a patient's body showing the exact location of the veins. So medical staff can hit the mark the first time when drawing blood or starting an IV prior to surgery. So this is what one application which maps a patient's body showing the exact location of the veins. So this is one how this AR is used with respect to the surgery point of view. just giving one example. And another application, reconstruct the tumors in 3D so surgeons can view X-rays in real time without radiation exposure. So this is another AR application. So one application, it checks with veins and sees where it is flowing, right? And another application gives a tumor size and with respect to the stages of the tumor without radiation exposure. And another function constructs the 3D visuals of organs from different angles for greater precision in stitches. So this, for the surgery point of view, there are some of the applications, AR applications, which are present day scenario, they are helping for the surgeries. So this is one scenario which I have just shown you. So which helps create interactive experience that show that they're training how new drugs and medical devices interact with the body, and also how the new drug is flowing and where it is, the flow of that also it can able to simulate, and then how what are the effects of that also can be able to simulate it. This is one of the, I think, all nowadays we are, earlier we don't know how to, what is this actually, right? Now this worksheet, right? So this heart, how it pumps, everything we can able to see with the help of the AR application. And there are some of the display devices coming to the research aspect point of view. These are the research display interfaces which I already mentioned, right? They're the wearable devices. See this wearable head-mounted wearable device, this device, and this device. The challenge is it should be mobile computing device. So it should be chargeable and battery powered, and all these aspects comes into the picture. And actual vision interaction and the visualization error should not be there. These are handheld devices, how it is locating. Here are some of the examples. Display devices, either wearable devices or handheld devices, and a spatial devices. So there are the developments with respect to the display devices point of view. And now next recent now is a retinal display device is there, where it is a inbuilt device where you can, it's not even a wearable device. I'll just move on to some of the toolkits. I just mentioned some of the AR kit. I think all of you are aware of this Apple. This has announced in the 2017 about the Apple's AR kit, where it is an application where you can overlay the images on the real images. You can see many applications with this. This is one simple example I am giving. And even Google also started with a AR core framework for developing an applications, AR-based applications on an Android phones or Android systems. There are some of the other softwares are there, like I was just mentioning, open source libraries. This is a Flash implementation of AR toolkit. This is a web-based application, AR tool, and this is also again web-based application tools. And what are the research challenges? And like as I was just mentioning that there's a huge data is travels, right? And with respect to that, how to retrieve the data and then how to display the data and relevant information, how to extract by displaying, by viewing the data is one of the challenge. And another thing is gaming point of view and entertainment point of view. There are again huge challenges with respect to the device point of view and the processing time point of view and the latency point of view. And what you can say is irrespective of the environmental conditions. You can say that photorealistic rendering, right? Irrespective of the environmental conditions, the images or virtual images to be embedded onto the real images with the exact size and location. With respect to the display device also, the visualization error should not be there, right? So these are some of the research challenges. So visualization error is one of the challenge, and there should be a tracking system that supports accurate registration on the exact location. Or accurate registration means accurately overlaying on the exact position of the real image. So that accurate estimation is required. That is one of the research challenge. And irrespective of the environment conditions, the illumination should not affect. So that is also one of the research challenge where you can address. And another research challenge which I just want to tell with respect to the security point of view, that is these are the devices. We are sharing huge information in the devices, and huge data is there across these devices. So if these devices are tampered, then
Hello, madam. Excuse me, madam. 1 second.
Hmm.
Madhavra sir, please kindly off your video. Madhavra sir, please kindly off your video, sir. Hello, Madhavra sir.
Hello.
Please kindly off your video, sir. Thank you, madam. We can continue now.
Yes. Okay. Thank you. And with respect to, we are discussing with respect to the challenges, research challenges. So tracking system is one of the identifying a good tracking system with respect to the navigation point of view, with respect to the tourism point of view, all right? So that is one of the major challenges, not only with respect to tourism or navigation, this is in all applications, military applications, marketing, and all these applications. Tracking system means here, you have to track it and then locate the images on the exact with respect to the real images. That is one of the challenge. So there will be some errors takes place. Those errors we are calling it as a visualization errors. So you have to minimize the visualization errors. So the performance metrics for these augmented related applications or implementing augmented AR based applications is the performance metrics is minimizing the visualization error is one of the performance metric. And another metric is how much environmental friendly is there or illumination friendly. That is also one of the metric for measuring the performance of AR based applications or mobile based ARs or web based ARs. These are the one of the metrics which you have to keep in mind while developing any application or any solution. And this slide I kept here because of the with respect to the security aspect point of view, what are the challenges? So this is a slide taken in the year 2019, January 2020. And this shows the time per day spent using the internet between the internet users aged 16 to 64. So our Philippines is 9 hours 45 minutes per day they are spending, and whereas our India is spending 6 hours 30 seconds. So on an average, all the age between 16 to 34, so they are spending on around 6 hours per day on this internet. So this slide, which I wanted to tell is, so this much of data is traveling across the space. And that data is, again, it can be a misuse or it can be any, may not be the content which is not useful, right? So these are the cases. They are all working with the devices. So what are the threats for that? So there are security challenges with respect to the AR and VR point of view I have mentioned here. So ransomware risk. Ransomware risk means I think all of you are aware of a ransomware attack, right? So the attackers will attack all the entire device control, and then they are trying to ask for ransom amount of money for giving those details, right? So that is ransomware risk is there with respect to the even with respect to the augmented reality and virtual wearable devices point of view. So hackers may gain access to users virtual or augmented reality device, that is a display device point of view, and they can also record their behavior and interactions in the AR or VR environment. So that means the hackers can get the device information, then they can hack the device, and also the behavior of the users with respect to the what are the history of the interactions with which way they have interacted, and then what is the environment they are working and where they have visited. All this information they could able to gain access. So that is the ransomware risk is there in with respect to the AR VR device point of view also. And another point of view, I think this all of us know this. So gaming website recently brought back to memory the 1997 episode of Pokemon that contained flashing strobe lights causing seizures in almost 700 Japanese children. That means this causes a health hazard. Health hazard is there because of this strobe lights. There is a most of the children got affected. So this is also one of the attack or a threat with respect to the device point of view. So there is a research challenge here also. Then how to provide security for these AR VR display devices, right? And applications. How to provide an security for these applications with respect to the client and server point of view, server based applications and as well as client based applications. And interference with the AR medical devices point of view. Hacking the device, that means control over the device loses. And sorry, it is repeated. So control over the device will be loses, right? Because particularly for the surgery point of view, if this they are trained with respect to all these devices and this device is hacked, then that's a one of the challenge. So that interference with the AR medical devices is one of the threat by the security point of view. So this is what the conclusion with respect to my talk. So I just wanted to give about a brief overview of what is introduction about augmented reality and virtual reality, and what are the applications, and then with respect to the application point of view, what are the developments in the existing literature, and what you can also address. And with respect to the security aspects point of view, I just wanted to give a glance about the threats with respect to the display devices point of view and then applications point of view. Thank you. Any questions?
Thank you, ma'am.
Thank you.
Participants, if you have any questions, you can ask, madam.
You can chat in the chat box. Otherwise, there is a disturbance
Hello, ma'am.
here.
I have a question, ma'am?
Can you chat it in the
I'm
chat
seeing
box?
Okay, ma'am.
Because there will be disturbance in talking, right?
Okay, ma'am.
Did you, any question? Is there any advantage of using AR/VR in online education? How far it will be useful? Obviously, there is an advantage. One simple example I have given, that is those you cannot explain, like even functioning of heart also, right? We cannot like we learn in the books only, but now we can able to show the actual function of how veins and artery works and how heart pumps per minute, like all these things we can able to see with respect to this, right? So for the memory point, learning objective point of view, it is very useful. Even electromagnetic physics principles which I have shown, and all functionality of the machinery, right? So even you can also simulate our laptop, like how from CPU control to the control instructions are taking sending to the CPU, and then CPU is working with taking the data from the cache, and then all these things also we can simulate. But I tried to see that, but I could not able to get it. I think if that is there, then so this is a good learning for the students, right? We are just explaining the architecture of the computer, but if you're able to show them the actual processor functionality with the help of this AR-based application, then obviously it's quite interesting, and they'll remember. It's like memory retention will be there for this concepts. Any questions from the participant? Yeah. So Avika, she requests that applications and tools require high amount of processing and space requirement. Is there any research there? Yeah, it's obviously that is true. With respect to the applications, tools are already, some of the open source tools are there, but there are like for processing point of view and space point of view, there is a GPUs are available, and even in TensorFlow, there is an where you can also take the processing speed and then work on that. You can hire that. You can, they are giving the process. You can also take the GPUs, work it on that, and then see the differences. So these hardware related issues are existing, are there, but this can be solved by high-end graphics cards. That is what I am saying, GPUs, graphics processing units. I think I have given answer. So you can address, even Google Collaborator is also there, where I think you can work it on these issues on memory requirements by solving with the help of GPUs.
Okay.
What are the even hardware related also? Yeah, coming to the hardware related, that is what I mentioned, right? Wearable devices. We should have the energy efficient wearable devices should be there. Energy efficient means should be battery powered, correct? And long run battery power should be long life battery should be there. For that, what you have to do is the device should be energy efficient or energy aware. Minimum usage of energy you should be able to do the processing. So
Okay. Next question is, what are the limitations of AR and VR as per research perspective?
limitations. What you can say with respect to the navigation point of view, driving point of view, I have given one limitation, right? So with respect to the limitations, with the applications, with respect to the navigation point of view, I can give the one limitation, right? So if the tracking system is there, the one example also they have given in the literature, the actual gazing of the road and then directions they have given, but actually placing on the simulation environment, it is exactly they can able to do, but actually coming on the road, the dimensions are missing. That is what actual locations are missing. So it leads to the accidents. So that was one of the disadvantage. So you can say that one of the challenge, like we are learning the car driving by using simulators and then actual driving. What happens? There's a huge difference, right? So similar to this.
Okay. Could we relate the AR VR with COVID-19 and how we can move in this direction? That is one more question, ma'am.
Okay, with, relate to
Could we
COVID-19.
correlate the AR and VR with COVID-19 and how we can move in this direction?
With respect to the learning perspective point of view, if COVID-19 means in this disaster condition also, we are using this, with the help of this AR and VR, we can able to online classes, this online sessions and virtual classrooms are taking place, right? So this is one of the advantage. But I didn't get the question like with respect to which direction this COVID-19 you were discussing with respect to AR and VR. Can I get the clarity?
Mr.
Sorry.
Satyajit Nayak, can you please retype the question? Madam actually didn't get the question properly. Ma'am, in the meanwhile, we can take one more question, ma'am. One more question is, how can we use AR, VR in behavior healthcare, ma'am? That is one question from Priyadarshini.
Yeah, that is what I was just telling with respect to the sentiment analysis point of in the beginning I was just mentioning, right? So behavioral healthcare means it is like analyzing the stress related parameters, right? So this AR VR that means you can analyze visualize the text from the from where this behavior patterns you will get, either from the Twitter data or from the WhatsApp messages or from the Facebook or Insta. You'll get these in, right? So these messages from this various social media platforms, collect those information and then visualize those information, because this is a huge data in various dimensions you have to visualize, and then analyze the sentiments or analyze the speeches, and then detect that what is the behavior of those patterns, that what they are chatting in that media. So based on that behavior, you can able to check you can able to give the health tips, or you can counsel the users. So this we can able to visualization point of view, data visualization point of view, you can use AR and VR.
Okay, ma'am. Thank you, ma'am. Now, yes, again, retype the question. For screening the COVID-19 symptoms at the preliminary stage. That is what his question is. Yeah.
Correct. Good. Okay, I got it now. Is it like we were discussing about this data visualization point of view, right? So this is same as like a data visualization, right? So there are n-dimensional data is there with respect to the symptoms point of view, right? So these n-dimensional data in a graphical representation or a visual format, we can able to see it, and then though now also we can able to see it in the visual format, but we are unable to inference from the minute points also. That is what symptoms, without any symptoms, these COVID patients, COVID cases are arising. That means there are some parameters which are there which you could not able to identify. So those insights can be traced by visualizing the data in n-dimensional directions. That can be done by, that may help us.
Okay. One more question, ma'am. Does VR experience affect the child's developing brain and vision? Because nowadays kids keep on watching this.
Correct.
Yes, that is one
So it is always trade-off. For every advantage, there will be a disadvantage, right? So obviously, there is overusage is obviously affects the vision, and effects are there. Right?
That in general terminal, like in general also watching mobiles and that also a kind of screen effect.
That is what, right? So there is always trade-off. That's what. For every advantage, there is a disadvantage is there always.
Yes.
So only we have to be in such a way that how to use. Now we have to train our children, that younger generation, that how to learn what to use and what not to learn, what to learn and what not to learn. We have to make them to learn.
Yes, ma'am. Yes, ma'am.
We have to tell them that what to learn and what not to learn.
Yeah. Any more questions from the participants? Okay. Okay, ma'am. It seems no more questions. Thank you, ma'am. I thank you for this interesting and informative session. Thanks for your gracious presence and being a speaker here. Thank you, ma'am. Thanks a lot.
Thank you for giving me this opportunity, and for coordinator and your head of the department, and convey my regards to them. Okay?
Sure, ma'am. Sure.
Thank
Thank
you.
you.
Thank
Thank
you. So I'm leaving now. Okay.
Okay, ma'am. Thank you, ma'am. Okay, I request all the participants to fill the attendance and feedback form, which has been shared in the chat box here. Kindly fill it and rejoin the next session around 12 o'clock after taking a small break. Thank you. Please, everyone, make sure that you're filling the form using your registered email ID only. Okay.